Good day. My name is James Blignaut, and today we're going to look at the economics of restoration and conservation, a brief reflection. And thank you very much for the opportunity to share some ideas with you. As these pictures indicate, nature is priceless. Pictures that I've taken in the Kruger National Park a few years ago when I was there with my family. It was priceless times that we spent together in nature. And nature, ecosystems, are highly, highly valuable, rendering services running into the billions of rands, as indicated in a recent study that we have done. And it's not even all the services that we were able to quantify. Many question marks, and therefore this number running into approximately 300 billion rand is but a lower bound estimate of the value of nature's services, what we as humans are deriving from nature in its form of ecosystem services. But when ecosystems or nature is broken, what do we find? It's leaking life, it's leaking resources, it's leaking water, it's leaking carbon, it's leaking nutrients, it's leaking productive capacity, it's leaking jobs. We can compare a broken ecosystem or degradation as having a motor car with a fuel tank, and that fuel tank having a hole in. And the bigger and bigger and bigger that hole becomes, the more and the faster we have to put fuel into the fuel tank to keep this car running smoothly going forward, but at higher and higher costs. So we have to take time out, reflect on the situation, and realize that we have to plug the hole, stop this leak from continuing if we want to run smoothly going forward. Because it is costly just to keep putting in fuel the whole time, and it is senseless in a sense. So restoration is like plugging that hole. Conservation is actually making that fuel tank bigger and bigger so that we can actually have more and more ecosystem services for the people of the country and to enjoy the services from conservation and from nature itself. And so the two, conservation and restoration, has to work hand in hand. Restoration, plugging the holes, stopping the leaks from the ecosystem to happen, draining life, draining resources for the current generation and future generations. And conservation is building this fuel tank so that we can actually run the engine better for the economy and for society as a whole. And therefore, in the recent past, a lot of money has been spent on restoration. One example thereof is of the Working for Water program, spending about 19 billion rand over the past 2.5 decades, working on 14.5 million hectares, generating 274, almost 275,000 full-term equivalent jobs. But this Working for Water program and the clearing of invasive alien plants, and then the follow-ups thereafter, because this money as well as the hectares includes both initial clearing as well as follow-ups, are a result of erroneous policies in the past, planting prosopis and wattle and afforestation in places where it should not be, conducting projects for different objectives in the past, but then has led to degradation. And now we have to spend a lot of money, and this 19 billion rand is but a fraction because the job is not done yet. And so we have to be very careful and very mindful of what kind of policies we introduce going forward, so that we don't start with policies today that's going to have huge consequences and costs tomorrow. Whereas the NRM program is a clear example of where we have to spend all this money to clear invasive alien plants, control degradation as a result of bad policies of the past. And so we should learn from this and not embark on afforestation projects in areas where it should not be, and commence a journey of bad policies again that should be changed around in future, and therefore be guilty of actually embarking on erroneous policies. But the Working for Water program is just one example of restoration, trying to offset the effects of and consequences of bad, erroneous policies of the past. South Africa has a rich history in ecological restoration across a broad spectrum of areas by both the public and the private sector. And we have documented about 250 such case studies across the country and categorized them in terms of soil, biodiversity, and agriculture benefits, as well as 7 others. So there are 10 of these templates, 10 of these maps, each of the teardrops, each of these markers representing a case study that's been published and documented. And if you click on it, then you will find the metadata reflecting about that specific restoration case study there. But gleaning then from this, we were able to summarize the benefits and the cost data of restoration from this literature. So, for example, for fynbos, we could find 18 studies that had documents benefit data and 35 studies that document cost data. And then for riparian areas, 12 that has got benefit data in and 8 that has got cost data in, and similar for the other ecosystems. And then building a little model comparing the benefits with the cost over a 20-year time frame, we could ascertain what the net present values are of the benefits and cost of restoration. And by looking at the mean values, the means of the benefits compared to the mean of the costs over time, we find that restoration does pay and does pay quite well. But there's a caveat in there. Because of the skewness of the data within both the benefits as well as the costs, the means could be very misleading. This is depicted when we look at the median, when the numbers are changing quite dramatically. And we even see the appearance of a couple of red numbers, which means that the costs exceed the benefit. Which basically means that we have to be very careful and very mindful of when we operate in productive landscapes. That yes, restoration can help us and must help us, and we have to embark on it much more actively actually. But it's very context dependent what the benefits and the costs are. What would be the purpose of the restoration? What would be the form of degradation? What would be the form of intervention? How far is that restoration site from infrastructure? What would be the topology of that specific site? What is the rainfall in that specific area? All these variables playing into the benefit and the cost of restoration. And likewise, when we look at the quartiles, quartile 1 and quartile 3, we see even more differences in the answers. Quartile 1 means that we're looking at the lowest 25% of benefits and compare them with the lowest 25% of the cost data, and we see that the costs are far higher than that of the benefits. In other words, the cohort 1 of costs exceeds the value of the cohort 1 in the benefits. When we go to the higher end, quartile 3, which is the cohort 50% to 75% of cost compared to the 50% to 75% cohort of benefits, then the situation does improve. When you go to quartile 4, then all of them turns positive. So at the top end, the benefits exceed the costs, but at the lower end, the costs are much higher than that of the benefits. That is depicted for us in this little graphic, with the first figure indicating the net present value when utilizing quartile 1, and the second entry reflecting the net present value of utilizing quartile 3 and comparing that to one another, with the red numbers indicating net costs and the green numbers indicating net benefits. But that is with respect to restoration. Let's consider concern ourselves a little bit with conservation as well. The extent of terrestrial protected areas in South Africa has increased from virtually nothing in the year 1900 to about 11 million hectares in 2020, or representing about 9% of South Africa's terrestrial biomass. That is a rapid increase over time. It forms a very large chunk of South Africa at the moment, almost 9% of the area already. And these protected areas, which stretches from national parks to provincial parks to protected areas to forestry areas to mountain catchment areas to World Heritage Sites, is a very broad definition of protected areas. This is that fuel tank, as I spoken of earlier, providing fuel for the engine to run forward, providing ecosystem services for the entire country. And so we can see that the fuel tank has becoming bigger and bigger and bigger, supporting the people of South Africa. Looking at one subset thereof, the budget of South African National Parks Board, we see that the total income has been about 2 billion rand in 2017-2018, and the total expenditure about 1.9 billion rand in the same year, requiring government grants of about 414 million rand. So what the conservation costed the South African taxpayer on a rand per hectare basis has been a fraction of that of restoration. It's far better from an efficiency perspective to conserve and to protect what we have on a rand per hectare basis than to restore. Enlarging the fuel tank is cheaper than plugging in the holes the whole time. Does that mean that we can just expand the PAs indefinitely? The answer is no. We can't expand the PAs indefinitely. It would not be possible. And therefore, when we do operate in the productive landscapes, we have to restore where degradation is. But we also have to tread very carefully not to cause degradation through bad policies or through the way that we handle and live on the land. Thank you very much.